And for today's program, today's world is interconnected. And in such an interconnected world, every business is international. So the old paradigm of English US first, non-English, non-US later is not sustainable. The program today focuses on the latest new technologies for enabling global readiness and geography from the get-go, and how we can make our products more relevant, accessible, and scalable. We always start a GlobalSaké event with a warm-up. Today, we're going to do something a little bit different. You know, life is transient, but a memorable moment is eternal. And so I've reached out to our GlobalSaké community, to you guys, to share memorable moments from around the globe.
We think about what are our current challenges, and when it comes to code internationalization, the biggest challenge that we have seen is the prevailing internationalization processes and technology in the industry, which is not good enough. What is NetApp's solution to that? NetApp's solution is Dr. Global, and we call it as a self-healing tool. The prevailing static code analysis tools are reactive, and that is because they work only when the issue has made its way into the source code. However, with Dr. Global, it starts working as soon as the developer is writing the code, and thus it becomes a proactive technology.
Continuous localization could be more than just file pushing. They can be building, testing, and performing other autonomous functions too. The large monolithic applications or scripts just don't scale. There are risks. Monolithic applications have gone the way of dinosaurs. So we can avoid monolithic applications by using individual microservices. A microservice is a little bit of functional code. It wakes up, performs a single task, and then it's destroyed. They're extremely fast and very cheap to operate. This is our microservice architecture. And the microservices in pink are distributed across a highly secure hybrid cloud environment. We're using Amazon Web Services and on-premises Kubernetes orchestrator called OpenShift.
We built a team in 2018, and we did some tests and so on, understanding which kind of content to go for. And in 2019, we launched MT in production. We did a little bit of in-game, marketing text, support material, and like that to understand if it was a good idea or not to go with all this kind of content. And now we have about 50% of the content using machine translation.
One thing that I really find unique with your team, working with other machine translation teams too, is just the sheer magnitude of your human quality evaluation program. I have this little graph here that I plucked from Content Qual the other day, just showing how the amount of those evaluations has changed. You can see the growth rate. And I can tell you that the amount of assessment and the amount of work done by Christina's team is really, really impressive. Christina, can you speak to utilizing real-time localization differently, I guess, for different types of games?
The first thing that comes into my mind is the language that the different people play in this game use. I mean, if you think about Apex, it's a super, super fast game. And also the kind of people playing this game, maybe the community is a bit younger, so the kind of language that they use is different from the language that is used in The Sims. The Sims is much more quiet and has a different pace. So this will be a challenge to really create system customized not to the language of the game, but to the language that the players speak.
So hi everyone, I am Rahul. Yes, I am from XTM and I am a computer scientist. I am a mathematician, so I'm going to talk about geeky stuff today. This is how we generate numbers from words. The output of this procedure is a dictionary, what we call a vector dictionary, which has words, and all the words are represented by numbers. When you train those vector spaces in languages like English, French, the problem is that you cannot really compare English vectors to French vectors, right? For that, you need another step. You have the vector space of English words, and you have the vector space of Italian words, and those two vector spaces are completely disjoint. But after applying these transformations, right, we can actually blend those two vector spaces so they are now overlapping, right? We then put all the vectors that we can possibly find into one single interlanguage vector space, and this is the technology that we are building.
John and I are tag teaming on this, and sorry, I'm going to speak fast because I'm from the East Coast, and John is too. Now you've got your source. Before you start localizing it into a myriad of different languages, we can see if that source is suitable for its purpose, right? Maybe it's not suitable for MT, but perhaps more suitable for transcreation. You think it's A, but in actuality it's B.
And then on the target side, we also need to also have checks and balances. Even with a trained engine, things go wrong, right? So we need to also be able to assess, and using some of these techniques, we could be assessing for, hey, once we actually get the raw MT, is there an extreme mistranslation? Is there not a correlation any longer between the number of nouns in the source and number of nouns in the target? That would be a problem for our knowledge base, right?
We'll present with Carrie a use case we had together between Sabian and Tantos on translating training videos.
Before I begin, little story. When I was a little girl, I would watch a TV show in America called Looney Tunes, and it was about this frog who could sing and dance. He only did it in front of one person. And whenever the one person would invite others over to watch the frog would turn into a regular old frog. This is how I felt, right? What everyone else saw in MT like 20 years ago, I was the frog. I was like, burp, I'm like, this is not going to work for Subway's content. It's too weird. It's too creative. What I'm going to focus on today is really the e-learning content, because that one is the one that surprised me. This is what I saw in the translation savings and savings for voiceover too. Just for the translation alone, for those 4 languages, we saved 46%. And we saved at least 2 months of time. And then the text-to-speech or AI voice, we saved 41%. And I estimated 1 month. I know that a human being can speak 10,000 words in 1 hour, and you can see the word counts that had to be spoken there. But there's so much else that goes into it, like finding the talent, approving the talent, getting the talent in there. And by the way, there's 8 people that you got to, figure out. But in 1 year, we saw over 1,000% return on our investments.
As being a consultant of FLSmidth and looking at the amount of text they have, 70% of all the text they are manufacturing is in the field of technical documentation. We try to find companies like Blend that could also be seen as a kind of IT company.
What we try to do is we evaluated a lot of engines out there, because this client requires a lot of language pairs to be translated daily. And so our first challenge was to choose the best one and to train it. And to do this, we needed to clean their data. We needed to annotate. We were able to reach editing distances of 3 to 7.5% in general. And this is not something that you encounter every day when you serve even the largest clients out there.
I'm gonna tell you a story about a customer. That customer is called Spacetoon. It is the largest TV station in the Middle East for content which is for kids and young adults. So they came to us with saying, okay, we need some AI to give the voices further life. So what's the solution? We don't build models ourselves necessarily, but we want to actually collaborate with everyone out there. And the goal is to build a system which is adaptive to cultural nuances for the target country and express emotions.
So the voice rendering, it's machine voice, that's very human, but the voice rendering needs to also then adapt to, for example, if in Japan, how you express excitement or
Very true.
astonishment, right, is different. I mean, the
Very
visual,
true.
the facial expressions are different, but also the voice,
the
and
facial,
the speech,
not only the facial. The facial is, I mean, you can survive without adapting too much, but the voice, I mean, if you're excited in one country and versus the other country, if you basically express the same phonetically, the same, or from the sound perspective, the same way what you do in Japan, in the Middle East, it sounds like almost aggression.
Right.
Something like that, even though it's not meant that way. So you have to do cultural adaptation of this tone.
And this is a sitar. So you see the picture behind me, Saraswati. She's the goddess of knowledge, illumination, and the arts. If you see pictures of Saraswati, you'll see there's always an instrument that looks a lot like this.
This is a little song, a melody that came to me when my granddaughter was born. There was a medical accident and there were very serious questions about her survival. So it was something that she inspired. Thank you.
Thank you so much.
Oh, thank you so much. That was so relaxing and spiritual.